Discuss about one new or interesting chapter in mathematics, which is complex number. Here the question is why. That means why we learn the chapter like complex number, or what is the uses of this. It is very simple. Complex number will be used to find the root of a quadratic equation. That means if one quadratic equation is present, so we will use for solving or finding the roots or solution of an equation of a quadratic equation by using or the help of complex number. And the second thing is, so in different engineering fields also we are using complex number, like in electronics and telecommunication, electrical engineering field. So in electronics and telecommunication or in electronics, there is one AC circuit is present, which is known as alternating current. And here that means in the case of the alternating current, so voltage and the current both are combined. So we can consider this voltage in one axis, that means in horizontal line in x axis, and the another, so current we can consider in y axis. So for finding this current and voltage we will use complex number, and also in electrical engineering field and also in the different like in civil and mechanical also we are using complex number. Now here I'll tell so how we'll find out the roots of a quadratic equation with the help of this. Now here I'll take the example. If one equation is present, that means we can say that equation means that is equal sign must be present. So for finding the value, first I'll consider one linear equation. First we will consider one linear equation x minus 2 equals to 0. So it is a linear equation. So that is we can find its solution, that means roots, that is x equal to 2. So it is a real number or any integer also. So but if the equation is like x square minus 4, it is a quadratic equation, then x square equals to 4, and this implies x equals to root over of 4, we can take it is plus or minus 2. That means it gives two values. Due to the quadratic equation, it gives two values, one is positive and another is negative. But another equation if we will consider x square plus 4 equal to 0, x square plus 4 equals to 0, then this implies x square equals to minus 4, and this implies x equals to the root over of minus 4. This is very important in that case. So we cannot find its value, that means the square root of a negative number. Till everyone knows in the number system up to the real number. That means we know in the standard 10 level, so natural numbers, that is starting from 1, and whole number it is starting from 0, and some integers, that means by taking the negative part of minus 1, minus 2, minus 3 and like that, that is called set of integers, or it is denoted by I or Z, and taking some fractions, if we will add 1 by 2, 2 by 3 and like that, so we will get a new number which is in the form of p by q. That means both p and q are the integers, but q is not equal to 0, so we can say that it is a rational number, and the number which is not rational, we can say that it is irrational, that is like root over of 2, root over of 3, but the combination of rational number and irrational number, we can say that it is a real number, that is denoted by R. This is the largest number we know up to this. But this real number is not sufficient to solve the equations or quadratic equations like x square plus 4 equal to 0. The real number is failure here for finding the roots or finding the solution of an equation like x square plus 4 equal to 0. But here solving to this type of equations, we are introducing a new number which is known as imaginary number. That means it is a number whose square is negative. A number whose square is negative. That means if we take the square of this part, we'll get -4. So it is known as imaginary number. The next. Now it is, what is imaginary number? The main part is, already I have told the definition from this equation. Already I have told what is the imaginary number. A number whose square is negative. So like -4, root over of -4, root over of -9 and root over of -11, etc. You can take any, not only the -4, root over of -4, -9, root over. You can take any negative root over. So we can say that it is an imaginary number. But to represent this square root of a negative number by using one symbol, this is called I, and it is derived from iota, and it is always denoted as I equals to root over of -1. This is also one imaginary number. After taking the square of this, we will get -1. So we can say that I equal to -1 root over. You have to remember this part. This is very, very important. Not in this level, also in your future, we can use this I equal to -1 root over always. Or anywhere -1 root over is present, so we can say that this is an imaginary number and it is denoted by I. Now we'll go for the next. How to represent this minus. That means here suppose -4 root over is present. Now we can write it is -1 root over and root over of 4. That is I and 2. So we can take this is in positive form. So I2. This I2 is also one imaginary number. And similarly we can write -7 root over of -7, root over of -9, root over of -16. So like that. Now we'll go for another part that is very, very important in our day-to-day life and also for solving the quadratic equations, integral powers of I. So integral powers of I means you can take the positive power of I also in the negative power of I, not a problem. So that is integral powers of I. So here I have taken some things. So like that, I already we know that is I equals to root over of -1. So what is I square? Very simple. So if we can take the square of this and also we can take the square of -1 root over of -1, and after that we already know, so root over and the square will be cancelled and you will get -1. This is very, very important. So now we can, how it is possible, just use. So that means I equals to -1 root over and taking the square of this, we can say that -1 root over square and this equals to -1. This is, and similarly we can find out I square. So how to find out I square? Now it is very simple. That means we can say that this is IQ, that is I square into I, and the value of I square is -1 into I equal to -I. Now similarly, this is I to the power 4 and this I to the power 4, not a problem. That is -1 into -1, that is y. And you have to remember this part. This is very, very important. So why? Now this is the power of I is 4. That means we can say that the power of I is a multiple of 4 or it is a divisible by 4, then the value is always 1. No doubt about it. So that means in the case of the even number, and this even number of I is multiple of 4 or divisible by 4, direct we can say that the value is 1. So now here I will go for solving some questions about how to find the power of I. Now here I will take one example. I will take one example. One example here, the power of I to the power 100. So this I to the power 100 is an even number, but it is this 100 is a multiple of 4 or divisible by 4. So we can write this is direct 1, no doubt. But every even number is divisible by 2, but all the even numbers are not divisible by 4. But we can find out this I to the power 100 by using another formula, format I square to the power 50. Just you divide it, I to the power 50, that means 100 by 2 equal to 50, and this is I square equals to minus 1, and minus 1 to the power 50 is equal to 1. We know that is the minus 1 to the power any even number is positive. This is very simple. If any even number is present, that means the power of I is an even number, you can divide it by 2, no doubt. And if it is a multiple of 4, then you can write direct 1. So I to the power 98. This is an even number, but this even number is not divisible by 4 or not multiple by 4. But how to find its value? Very simple. You just divide it by 2, I square to the power 49. This is minus 1 to the power 49, and the value will be minus 1, due to we know minus 1 to the power 49 equal to negative. So similarly, how to find the power of I is an odd number? So that means I to the power 99. This is an odd number. I to the power 99 is an odd number, but how to find its value? Very simple. Just you open one I. That means I to the power 98 into I. You just open one I, then the power will becomes 98. That after subtracting one I here. So this I is an even number. Now you can transfer it I square to the power 49 into I, and this equals to minus 1 to the power 49 into I. This is minus 1, minus 1, minus 1. This is equal to minus 1 into I equals to minus I. So this is the answer, I to the power 99. And similarly, if the value is present like I to the power 101, the power of I will be 101, then how to find out? Same method you can apply here, I to the power 100 into I. So then you can proceed. This value is 1, that is 1 into Y, and the value will be I. So this is even power of I, how to calculate it, and this is odd power of I, so we can calculate by making in the form of even power. So this is very simple, and we can find out the power of I. So in this way, either the power of I is an odd number or the power of I is an odd even number. So if it is even number, you can calculate in this way. If it is odd number, then you can calculate in this way. Very simple. This is about the power of I. So in the next slide, I'll tell about so what is the evaluate I to the power 2000? So evaluate I to the power 2000. This you can see I to the power 2000 means it is a multiple of 4, and it is multiple of 4 means the value will be I. And similarly, here another question is I have taken. So evaluate I to the power 2001. Out to power 2001 means this is an odd number, and you can make it I to the power 2000 into I. And this I to the power 2000 already we know. So this is 1, this is 1, and this is I to the power 2000 equal to into I equals to, that means we can say that that is 1 into I, and this equals to I. So this is very simple. So now you have to remember another part is here. Another part is 1 plus I square plus IQ is equal to 0. So how to remember? So very simple. The sum of the 4 consecutive power of I. The sum of 4 consecutive power of I is equals to 0. That is very simple. You remember what is this? Now 1 is also I to the power 0. You can write I to the power 0 equal to 1. And this is I to the power 1. This is I to the power 2 and I to the power 3. That is the sum of 4 consecutive power of I, and the value will be 0, no doubt. So you have to remember this part. Now I'll tell here one thing. So one example here I'll take. So one example. So that is I to the power n, I to the power n plus 1, I to the power n plus 2 and I to the power n plus 3. That is also 4 consecutive powers, n, n plus 1, n plus 2, n plus 3, and the value will be 0, no doubt. This is very simple also. That means you have to remember this part, the sum of the 4 consecutive power of I is equals to 0. Okay. Now we'll go for the next. So this is about the imaginary numbers and how to calculate the power of I. Now we'll go for the best thing. So already I have told in the starting what is complex number, and here the complex number is this. So we can write a number in the form of x plus iy. That means z equals to x plus iy. That means here it is a combination of a real number and also the combination of imaginary number. That means x is a real number, iy is an imaginary number. That means it is a combination of two things, that is real and imaginary. But x and y both are the real numbers, not both are the imaginary or other things. That is, both are the real numbers. So here I have written x, y belongs to R. R means set of real. You will consider any real number, not a problem. Any real number, then you can make it x plus iy form. So we can say that this is a complex number, and always the complex number in the form of x plus iy. In every complex number, two parts are present. In every complex number, we have two parts. One is a real part of, and another is imaginary part. So this x is only real part. That means there is no multiplication of I. That is, x is called the real part of z. That means z has two parts, x and iy. But the real part of z is very simple, x. And another part is only y, not the iy. So imaginary part of z is y. So that means we can say that here real part of z is x and imaginary part of z is y. So in every complex number, suppose one complex number here x is, I have taken one example, z equal to 2 plus i3. If we compare this 2 plus i3 with x plus iy, then 2 is called the x, but 2 equals to x and y equal to 3. That is very simple. Just so here x equals to 2 and y equals to 3. That means you compare this 2 plus i3 with the complex number x plus iy. That means x equal to 2 and y equal to 3. Here 2 is the real part and 3 is the imaginary part. That is very simple. Now take more examples here. So some examples here I'll take. Suppose one complex number is present like 2 minus i3. If the complex number is present like 2 minus i3, it's very important. You have to prepare, or you have to make any complex number in the form of x plus iy. 2 minus i3 is present, but you have to transfer it in the form of x plus iy. But how? So you can make it 2 first, then you take the positive part, no doubt, then you can take I, then you can take the y part. This is very important, very important. So 2 minus I3, how to form in the form, how to make in the form of x plus iy? This is 2 plus I, then minus 3. First you write the real part, then you write the plus sign, then you write I, then you write the y part. It may be positive or negative. That means here we can say that x equals to 2 and y equals to minus 3. Similarly, if another example here I'll consider z equals to minus 2 and minus I3. So how to transfer in the form of x plus iy? Very simple. You take minus 2, no doubt, minus 2. Then you can write plus sign. Then you can write I. Then you can write minus 3. That is minus 2 plus I minus 3. So what is x here? Minus 2. So what is y here? Minus 3. That's complete. Now this is another example. Suppose z equals to only 3. That means there is no I part. So how to make it? This is very simple. You can 3 plus I into 0. That means we can say that x equals to 3 and y equals to 0. And similarly, if another example is present like this, z equals to only 2y, no real part is present here, then how to make it? If real part is absent, so you can write 0. If imaginary part is absent, then you can write 0 into I. That is 0 plus I into 2. Then what is x here? 0. Then what is y here? 2. This is very simple. If any number in the form of 2 minus I3, always you have to transfer any number in the form of x plus iy. That is very, very important part in here. You have to write all the numbers in the form of x plus iy. That means in the complex number form. So after the completion of the complex number, this is the number system chart. Already I have told in the standard 10 level, everyone knows up to the real numbers. That means it is the natural number denoted by n, that is starting from 1, 2, 3, whole number after including 0. So we can say it is denoted by w. Then you get integers, it is denoted by I or another letter also z. And after that rational numbers, that is denoted by q. Then this is real number r, denoted by r. So this is up to 10th level we know. But here we will add one new number, that is imaginary number. And this imaginary number, after adding this imaginary number, we will get one complex number in the combination of a real number and imaginary number. If it is only imaginary number, then it is complex number. If it is only real number, then it is complex number, no doubt. This is the about number system chart. Now, so after that, after the completion of the complex number, some definitions are related to complex number. Which one is conjugate of a complex number? Very simple. So in the 10th level also we know that the conjugate of 2 minus root 3, that is 2 plus root 3. And similarly, here the conjugate of a complex number is very simple. You have to remember just. So what is the definition? It is very simple. If z is a complex number like x plus iy, then it is denoted by z bar. Conjugate of a complex number is denoted by z bar, and it is x minus iy. So the definition is like that. If z equal to x plus iy, then the conjugate of a complex number is denoted by z bar, and which is obtained by changing the sign of the imaginary part. This changing the sign of the imaginary part. That means minus iy. If it is x plus iy, then it is. In my point of view, just I'll tell one thing. You just change the sign before I. Very simple. You remember this point. You just change the sign before I. If I is anywhere, then you can change its sign, but you will get the conjugate of a complex number. That means one example here I have taken, z equal to 2 plus I3, then the z bar. What is the z bar? Here this is the question mark, I'll tell. So z equal to 2 plus I3, then z bar equals to, what is the answer here? 2 minus I3. This is the z bar. Z equals to 2 plus I3, so z bar equal to 2 minus I3. Just to change the sign of the imaginary part, or just to change the sign before I. What is the sign before I? Plus. You can change it minus I. So you will get the answer. Very simple. The conjugate of a complex number means, in my point of view, just to remember, change the sign before I. Now we'll go for the next part. Some examples. Suppose one complex number is present, z equal to 2 minus I3. Then what is z bar? So the z bar is, just you change the sign, that is 2 plus I3. That means just change the sign before I. Minus I is here, then you can change it plus I. Suppose one question is another is present like that, z equal to minus I plus 2. Minus I plus 2. Don't make in the complex number form. So what is z bar? You just change the sign of this before I, that is plus I plus 2, or we can write this is I plus 2. I plus 2. This is the answer. That is conjugate of a complex number. Now another thing is, if z equals to only 3, if z equals to only 3, then what is the conjugate of this complex number? Very simple. There is no part of the I or imaginary part. That means you can make it 3 plus I0, no problem. But here the imaginary part is 0. So the z bar is very simple. That is 3 minus I0. And that means we can say that this is also 3. There is no change. What is the meaning here? Just to remember one note. If z is a real number only, that means the conjugate of a real number is the number itself. If 3 is present here, then the z bar is also 3. There is no change. That means already I have told, the conjugate of a complex number means you just change the sign before I. There is no I part. Don't change its sign. So we can say that this is 3. Now, if it is z equal to minus 3, that is also a real number. There is no part or imaginary part. So we can say that z bar equal to minus 3. No change. That means the conjugate of a real number is the number itself. You have to remember this. The conjugate of a number is the number itself. Okay. Now, the another part is here. So if we'll take z is a complex number like x plus iy, and z bar equals to x minus iy, then what is this whole bar again? Z bar already we know. If we take the again bar, then it will be x plus I to z. Very simple. What is the rule here, or what is the point here? You have to remember, the conjugate of a complex number is the complex number itself. Z bar whole bar equals to z, no doubt. If you take any example, no problem. If you take z equal to 2 minus I3, z equal to minus 3, no problem. Z equal to minus I plus 2, always you will get this. This is one rule. You have to remember it. Z bar whole bar equals to z. So this is about the conjugate of a complex number. So conjugate of a complex number, you just remember, very simple way you just remember, that is you just change the sign before I. Now we'll go for this. Thank you everyone.